In the first part, we do the simulation about the half-wave rectifier with different load conditions without capacitor filter, followed by the half-wave rectifier with capacitor filter. In half-wave rectifier, the DC output might not be constant because of the unnecessary ripple in output voltage. The ripples are the unwanted AC part present in the output DC. For the first load condition with resistive load only, the green line of the graph indicates the AC input voltage, while the blue line indicates the DC output voltage. For the half-wave rectifier with resistor, the result shows only the positive part of the waveform because it already removed the negative part of the AC input, then produced the partial DC output. When passing through the diode, it only allows one direction of flowing current. At the positive part of half cycle, the diode is turned on, which allows the current passing through load resistor. Thus, the load voltage will follow the positive half sine wave. However, the diode is turned off during the negative half cycle and blocks the current. Hence, there is no voltage during negative part half cycle. For the half-wave rectifier with resistive load and inductor, the result is shown as below. The green line indicates the AC input voltage, while the blue line represents the DC output voltage with additional inductor. The gray line shows the waveform of a resistor at 50 ohm. In order to let the inductor work significantly, the frequency is changed from 50 Hz to 50 kHz throughout the whole experiment. In positive half cycle, inductor stores energy in magnetic field that generates the voltage. When the voltage passes through the inductor, its polarity has changed and becomes negative. The average output voltage becomes less if compared to the resistive load only. When a bypass diode was added into the circuit in parallel with resistor and inductor, the result shown as below. The green line shows the input AC voltage, while the blue line indicates the waveform of inductor and the gray line represents the waveform for a resistor with additional bypass diode. The bypass diode helps to prevent the negative voltage by providing an alternative path for the current to flow through during the negative part of supply voltage. Thus, it is obviously shows that the voltage across the load will always be positive when it passes through the resistor, which represented by the gray line. The half-wave rectifier in three conditions, which is with resistive load and inductor, resistor, inductor, and bypass diode with the capacitor filter will show the same result. The main function for this filter is to allow the AC components and blocks the DC components of the load. The filter circuit output will become a stable DC voltage. The capacitor filter has moved the pulsating DC output voltage into stable DC output waveform. The capacitor will be charged to the highest rectifier voltage value that is denoted with Vm, and then the voltage of the rectifier starts to reduce. As this happens, the capacitor starts discharging through the voltage across it and load. The voltage across the load will reduce later only because the next peak voltage occurs instantaneously to charge the capacitor.
As shown in the figure, the full wave rectifier converts both positive and negative half cycle of the input AC signal into output pulsating DC signal. During the positive half cycle, diode D2 and D3 will conducting, and during negative half cycle, diode D4 and D1 will be conducting. Hence, during both the half cycle, the diode will be conducting. The output waveform after rectification will be as this is the full wave rectifier input and output waveform without filter. When capacitor filter is not used, then the full wave bridge rectifier just acts as a normal rectifier giving a complete positive output source of the given waveform, converting negative half cycle to positive. As a conclusion, we can conclude that half-wave and full-wave rectifier circuit can be built. It can measure and record their output voltages and curves systematically. The influences of load resistor and capacitor on DC output voltage is investigated. Half and full-wave rectifier are used to convert AC into DC voltage. This is the primary function of the rectifier in industrial application. AC is used across the power grid, but to use electricity for welding, electroplating, and as a DC source for motor with special speed control, the AC must be changed to DC. Therefore, it is important to carry out this experiment to increase the understanding of rectifier in industry. The analysis from the report shown that capacitor filter can be purify the DC output by decreasing the unnecessary ripple. That's all from us, Group 4. Thank you. Assalamualaikum and greetings. This is voltage divider bias circuit for transistor experiment from Group 4. What is transistor? Transistor is a semiconductor device which refer a weak signal from low resistance circuit to high resistance circuit. Words mean transfer property and Easter mean resistance property offered to the junction. In other words, it is switching device which regulate and amplify the electrical signal like voltage or current. Next, the transistor consists two p-n diodes connected back to back. It has three terminals, namely emitter, base, and collector. The base in the middle section, which is made up of thin layer. The right part is called emitter diode, and the left part is called collector base diode. The names are given as per the common terminal of the transistor. The terminal base junction of the transistor is connected to forward bias, and the collector base junction is connected in reverse bias, which offer a high resistance. So what are BC and BE junction? So the BE junction is forward bias and the BC junction is a reverse bias. So forward bias of the BE junction will cause the injection of both hole and electron across the junction. The holes are of little consequences because the doping level are adjusted to minimize the hole current. The electrons are the carriers of interest. So the electrons are injection into the base region where they are called the minority carrier. Meanwhile, the electron in BC junction encounter a potential gradient due to the depletion region and are swept across the junction into the collector region.
For question number 2, biasing in electronics is the method of establishing predetermined voltage or currents at various points of an electronic circuit for the purpose of establishing proper operating conditions in electronic components. In this experiment, mass biasing and voltage divider biasing configuration are used for transistor. One way to bias a BJT transistor is called base bias. Base bias ensures that the voltage fed to the base VBB is the correct voltage, which then supplies the correct current so that the BJT has enough base current to switch the transistor on. Here is the two biasing method configuration. A voltage divider bias is a method used for the DC biasing of bipolar junction transistors BJT in a simple amplifier circuit. The circuit usually consists of biasing resistors in a voltage divider network whose values are determined through circuit analysis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nabila Aisyah. In the experiment 3 voltage divider bias circuit for transistor, in this video I will answer the question number 3 and number 5. For question number 3, explain the circuit and simulation performed. This is the result that I get from my simulation that I have done. So for simulation base bias circuit using Q1 and Q2, this is the circuit that I get. And this is the circuit that I get for voltage divider bias using Q1 and Q2. Next one, I want to show the data sheet that I get from the simulation that I have done. 7.1 shows that base voltage measurement. Next one is 7.2 shows that voltage divider bias circuit.
This is the result for simulation for transistor 2N3904 where beta equals to 200. With the computed value that we got, we calculate the VC with this formula, and then we get the VC is equal to 7.518 volt V. And the result simulation for transistor 2N2222 where beta is equal to 75. This is the computed value, and with the computed value we get VC is equal to 10.315 volt. This is the result voltage divider measurement with different value of resistor for transistor 2N3904 where beta is equal to 200. Thus, with the computed value we got, we can calculate the value for VC, which is VC is equal to 5.8143 volt. And lastly, the result for voltage divider measurement for transistor 2N2222 where beta is equal 75. With the computed value that we got, we can get the value for VC, which is 6.3654 volt.
Okay, next one for question number 5. What did you learn from the experiment? So in this experiment, I learned how to construct and analyze a base bias and a voltage divider bias circuit. And also, we learned the type of transistor and how it works.
In conclusion, voltage divider bias method is more stable than the base bias method as it is a ratio and independent with the BDC. The existence of RE provides stability against difference in beta, which increase the output current IC. The steady state of the transistor operation is hang on the Q point which associated with IC. The output effect of the base bias will be worse than voltage divider bias as it is affected purely by the amplification factor of a transistor. Therefore, the biasing point will differ widely if the value of beta DC change a bit. Hence, less bias method is not popular where and rarely being used due to its poor stabilization if beta changing, although it is easier to design. Thank you.